I have a tendency to walk off these things. Okay. Are we getting audio in from this thing decently? Oh yeah, I'm driving that like a mother. All right. And now we just... Okay, sorry. I'm so used to running these things by myself, unless it's something like DerbyCon. All right, everybody. Hello. The presentation I'm going to be giving is on, and I'm so paranoid about things, always getting this recorded, because I've done this talk one time before, but I wasn't able to record it at that point. But luckily, now I can get this up on the internet for the masses. But my talk today is called Character Assassination, Fun and Games with Unicode, and largely was a big excuse to be able to do that animation. Okay, a little bit about me. My name is Adrian Crenshaw. I run irongeek.com. Hope some of you all visited the site. I have an interest in InfoSec education. I don't know everything. I'm just a geek with time in my hands. If I get something wrong, come up and tell me. I'd like to know the truth. And I'm also an information security engineer at a Fortune 1000 company and co-founder of DerbyCon. All right, just to be clear what this talk's about, in case you read the schedule and thought it was about something different, this talk is about Unicode, not unicorns. All right, so anybody that's interested in unicorns, I think that unicorn is someplace out in the building right now. So why this particular subject? Lots of research has been done, but not many people actually seem to talk about it at conferences I've seen. We'll talk about one guy who does a little bit later in the credits section. Complexity is like the damnable enemy of security in many ways, because it's hard to get something really complex right. Simplicity, a rock is a pretty secure thing. It's nice and simple. Door locks, however, much more complicated and not necessarily the most secure in the world, depending on what you get. So the Unicode spec is pretty complex, so it's something to be looked into if you're looking for bugs. Also, this talk I hope will act as a setup for future talks. Basically, I can go, okay, I'm going to talk on Unicode, but to understand what I'm going to talk about here, here's another talk that just focuses on the beginnings of security problems in Unicode. And I hope they will also encourage other people who are better developers than I am to look into bugs in Unicode implementations and find some new flaws that people can use and then fix them. Also because I want to make that animation at the beginning, as I always stated. So why does Unicode even exist? Well, there's more than just English speakers out there. And ASCII, which is what we normally think of as plain text, stands for American Standard Code for Information Interchange. And as long as you're speaking US English, it's pretty much everything you need. However, not everybody speaks American. So you have to cover other types of languages and other types of character sets, like Cyrillic, Chinese, Hebrew, Arabic, and Klingon. Klingon's not technically in Unicode, although people have set aside their own part of Unicode that you can sign the way you want, and someone has mapped that for Klingon as well, if you ever want to see that. Unicode also lets a computer system support more languages, so it allows for worldwide use. Now, to start with, ASCII is not 8 bits. ASCII in and of itself is 7 bits. You have 96 printable characters, and the 8th bit was added to make some other standards. Well, actually, since the nature of the computer, they had the 8th bit anyway, so they might as well use it. So you have different types of extended ASCII. You have normal extended ASCII that you see on the old IBM PCs, and a lot of this is still held over today. And you also have ISO 8859, which is used for mapping that later part, that later bit, and the extra characters to different nationalities. So you might have a character set, you might have a certain ISO encoding for, well, Latin would be the normal one we use. You might have a different one for Chinese, for Cyrillic, and so forth. And this will allow you to specify those upper 96 characters to be something different in a different language, depending on what your page code is. But this is still not enough. Adding another 96 characters is not quite enough to take care of it. By the way, the reason it's not 96, it's not something like 128, is because in theory they're supposed to use those control characters at the beginning for something different. So there's a section that's not supposed to be normal characters. But 96 still doesn't take care of it. You need more code points than that. So that's where Unicode came in. Now, Joe Becker from Xerox and Lee Collins and Mark Davis from Apple started working on this back in 1987, and version 1.0 came out in October 1991. So it's been around for quite a while. Unicode started out as a 16-bit character model, so 0000 FFFF, but it's been expanded since. And the first 256 code points are the exact same as ISO 88591. And this allows some backwards compatibility so that if you're reading a file, it could be Unicode or it could be the ISO standard in ASCII, and it would still work okay. And to give you an example, for some of the characters that are mapped in Unicode, like A, that would be, oh, sorry, I'm on the wrong screen there for that. A, that'd be use Unicode point 0041, $sign would be this, knight symbol from chess would be 265E in hexadecimal. Now, they've had to expand it out, though, because even at 16 bits, that wasn't enough characters. So they've enhanced that somewhat, and now you actually have more code points than that, so somewhat over 1 million code points in decimal. And most of the points you're going to be using, though, are what's called the basic multilingual plane, or BMP, and that's everything from 0000 to FFFF. Okay, there's different ways you can encode Unicode characters. It's not like one standard, like with ASCII, that 41 in hex is an A. I did get that right? Uppercase A. It's always that, but it doesn't vary. However, Mozilla crash report, oh, crud. Let me restart that. It's always that. But with Unicode, there's different ways of encoding things. And the most common is what's called UTF-8, USC transformation format 8-bit, and it's meant to be backwards compatible with ASCII. So if you're only using the normal ASCII characters, binarily the file should look exactly the same except for the BOM, which I'll get to in a second. But that'll allow you to still read the file even if you have a non-Unicode supported system. UTF-16 is similar in, well, it's everything's like 16 bits for all the character encodings, except for certain high order characters, which we'll talk about here, the ones that they extended to make that over 1 million characters bit. And there's also UTF-32. And UTF-32 is actually the simplest of the formats, which I'll get to. And what file format you're actually talking about depends on the BOM that's attached to the beginning of the file. For instance, UTF-8, it'll have this EFBBF to data. This one here, UTF-16, it'll have that string of bits put to the beginning, and UTF-32 generally doesn't have a BOM. But to give you an idea what a BOM looks like, let me see if I can get that up and running without screwing anything up. Okay. Let me up one. I'm going to show you what a BOM actually looks like. Like here's some corrupted Unicode that I'm going to be playing around with later on. If I was looking at this at a hex editor, I would see a particular BOM that tells me, oh, this is a UTF-8 formatted file. So a text file is not necessarily a text file, it's not necessarily a text file. Things do vary. And you can also have UTF without it necessarily having a BOM at all. That's another option. But how these things are encoded, and you know what? I realize this is probably going to get boring after a certain point when you're talking about code, so let me show you something you can do with some of this knowledge before I even continue. All right, let me bring this up. All right, we got some files up here that, oh, you know what? I just realized it never came up on the screen, did it? Why didn't y'all tell me? Dude, messing around with two screens like this messes with my mind. All right, let me get that back up and show you what I meant to show you before. Display settings, duplicate slideshow, and that just makes life a lot easier. Maybe it does. Brian, did this come back up over there? Or did it lose it when it switched resolutions? All righty. Let me show you again what I meant to show you because I didn't have the right screen up. All right. See this file right here? This is some corrupted Unicode. And if I looked at the beginning of it in a hex editor, you'd see that BOM I was talking about. It tells me what kind of file it is. Or technically it should be a little bit more than that. I'm trying to get all those characters. that's the bomb that tells me what kind of file format it is. Let me go back into PowerPoint now. Now, the way these things are formatted, let's say you want to encode the string A, omega symbol, B. There's different ways you can encode that. In UTF-8, that would actually be 41 CE A9 42. In this case, each byte of the file is not necessarily one character. Someone who knows more about security than I do on Twitter said something to the extent of, oh, you got to fit that 140 bytes. I'm like, Twitter's not 140 bytes. It's 140 characters. Because in UTF-8, this omega symbol is actually 2 bytes. When you represent hexadecimal, each character in hexadecimal represents 4 bits, so this is a total of 2 bytes. UTF-16 is actually the simplest of them. Here it's simply encoded as, oh, by the way, notice in UTF-8, 41 and 42 for A and B, same thing as it is in ASCII. Now for UTF-16, every 2 bytes is 1 character, so that does stay the same. It's not variable byte lengths depending on the type of character. Actually, no, that's not true either. Yeah, that's not quite true either. But we'll get to that in a second. Right here, we have the same thing encoded, and you see that they use the entire 2 bytes to represent it. And since this is code point 03A9, that's exactly what's in the UTF-16 file format. It gets a little weirder when you get to those characters that are above 16 bits for representing the code point. Now 32, it just uses 32 bits to represent it. That's nice and simple. Now it gets a little weirder when you use some other characters. Like this is for a grain of rice, I believe it's Chinese. And that's how it represents it. And how UTF-8 works is a little complex. 16, it's nice and simple, at least for everything that's in the BMP, the basic multilingual plane. So, by the way, going back to why this exists, going back to the way people used to use 8-bit ASCII and get around the character limitations, there were certain implementations of that that were better than others. Who's ever had this kind of crap on the top line show up on one of their documents or when they're web surfing? The reason it does this is Microsoft made their own standard of sorts. It's very similar to ISO 8859-1, which is basic Latin, except for there were certain character codes that the ISO standard used that were considered control characters. But Microsoft decided, no, I'm going to put my own characters in there, which are those smart curly quotes and all that crap. So if a web browser misinterprets what format it is, what format that text file is, it may show question marks, or it may show the wrong type of quote, and it's a major pain in the butt. Also, sometimes things autocorrect for you. Like some Office products used to have a major problem with this. You paste in source code with quotation marks, and then all of a sudden decide, oh, I'll correct that with smart quotes for you, and it screwed up your source code if anybody tried to copy and paste it off your website, which was a pain. But I figured I'd just let you know why you actually get those weird smart quotes in CRUD. Oh, another thing you might notice, anybody ever looked at an email, saw a smiley face, but in the preview it was a J? Ever wonder why the hell that was? Apparently in Wingdings, the J character is replaced by a smiley face, but depending on whether or not the thing you're using understands fonts like that, it may show a J instead. All right, UTF-8 is, well, varying byte lengths for different characters. The way they try to encode it is, let's say you can represent in 7 characters, it's just the normal 7, sorry, even if you can represent in 7 bits, it's just the normal byte that you would use. So those lower 7 bits of a byte represent the character. Now, if it would take 11 to represent it, then you have these continuation bytes and the beginning of the byte, and this beginning few bits tells you how long that particular UTF-8 string is going to be to represent one character. Now, if this is making your brain go, huh, what the hell is this going on? Well, that's one of the reasons that there are some flaws in some Unicode implementations, because it does get kind of complex fairly quickly. And I can show you some ways of corrupting Unicode later on that utilize this. So if you have something that might take 31 bits to encode normally, this is how they spread it out. So it's actually a 6-byte character. That goes back to my whole thing. Twitter is not 140 bytes, it's 140 characters. Okay, UTF-16, that's fairly simple for most things when you're in the BMP, the basic multilingual plane. Now, when you get to something higher up, though, it gets more complex. There's certain things called surrogate pairs. See, in 16, all right, for things to work the way they need to, you want everything in UTF-16 to be 2 bytes for the characters, and the way you end up doing that is you use surrogate pairs, and these 2 surrogate pairs together, well, here's the algorithm for doing that. Let's say you have a 20-bit number in the range of this particular code point to this particular code point. What you end up doing is you take the top 10 bits of a number in the range of here, which are added to D800 to give you the first code unit of the lead surrogate, which will be in this range. And then for the lower 10 bits, you're also in the range of here to here. So basically, you actually use 4 bytes to represent that upper character, and use surrogate pairs, which are set aside to represent all that. And I'm not really doing a good job of explaining how it works, but basically you have a set-aside branch, and you use 4 bytes to represent those higher order ones, and not screw things up, and still keep everything, you know, nice and well done. Now, if your implementation doesn't actually read UTF-16, these characters that are in that higher plane are going to be kind of messed up. The lower 10 bits, let's just continue on with this. It's complex to explain, and you can check the slides out later on, but this is how higher order things in a Unicode are encoded if you're using UTF-16. Now, Mojibake, I already talked a little bit about what Mojibake is earlier. I just didn't announce it as that. Mojibake is a term that means character transform. I was mentioning how sometimes if it doesn't understand your character set, you get those question marks and crap. Well, that's an example of Mojibake, something that's not interpreted properly. For instance, I have this particular string, which in UTF-8 looks just fine. And this is all the code points that make it up. And I've color-coded them so you can see which one matches with which. But let's say in UTF-8, that byte string would look like this, because I have the bomb there to tell what format it is, that EF, BB, BF. So if I looked at that in something that thinks that the file is ISO 8859, like I went out to a command prompt and just said, you know, type this out, I'd get Mojibake, because it tries to interpret all of those bytes as this, what it would be in ASCII, in straight up normal ASCII, probably IBM extended ASCII. Now, you might be wondering, how do you find your character if you want to know what code is what? Well, there's a bunch of great sites for that. There's a Wikipedia list that has pretty much everything. Unicode table, which is also nice, but I like file format and Unicode code converter, and I'm going to show those real quick. All right, here is file format info, and you can type in a word and describe something and find that particular character. Like in some of the extended stuff in a Unicode, there's a little symbol for a pile of poo. And also, if you want to and don't know what something is, you can type it into this other site, rashada.net tools/conversion. And let's say Adrian. If I wanted to convert that to different formats, it shows me the characters I have in here, what it is in UTF-8, UTF-16, and it shows me the representation. This also allows me to type in the hexadecimal representation of the code point and be able to get back out the character, which is real convenient from time to time. So if I just was to type in like some random, I don't even know what this thing is, I don't know if it is a character. If I was to type that in, it would try to convert it for me, and apparently it's some weird Predator's laser pointer looking symbol. But those are all useful sites for figuring out what character is what. And if you want to type Unicode, you can do that also in Windows. You can use the hold down Alt, type it on the numpad. But to make that work right, there's a registry entry you have to do. Otherwise, you'd be doing like IBM Extended. Like, well, I don't know if I have the registry entry set for this right now, but you can type that way just using the keypad, though usually it's easier to go out to that Rashada site I pointed out before. Also, you can do it in OS X if you really want to. I'm sure there's a similar way of doing it in Linux. I just haven't really looked into it. And my obligatory XKCD slide. I don't know if I have my obligatory lolcat slide in here or not. We'll talk about diacritics here in a bit. I was screwing with people on Twitter a few months ago with using a diacritics. Okay, first type of security concern we're going to talk about with Unicode. Now that you have the basics of how Unicode works and there's different ways of encoding it. Homoglyph and visual attacks, which I'm going to spend very little time on, hopefully, because it's, well, I don't know if it's going to be completely solved, but it's largely been solved. It's not nearly as big an issue as it was a few years ago. But let's say you want to phish somebody. Well, obviously, if I send you a bunch of links claiming to be your credit card company, but all of them lead to Adrian's House of Ponage, you're probably not going to click on those links. That would probably be a dumb idea. Now, people have tried to obfuscate this by doing things like embedding one link with a different text tag. But this is real easy to spot as spam, because if someone's doing that, there's probably no real good legitimate reason for doing it. So they see the text is Microsoft.com, but the actual link is IronGate.com. Any kind of spam filter is going to go, yeah, I don't think so. For a while there, and I used to do this prank. This was a prank I did in the late 90s to somebody. It was April Fool's Day joke. I was trying to convince them that Apple was switching to an Intel-based platform. Who knew? Actually, specifically, it was actually AMD that I said they switched to. The way I ended up cloning a site was I took like the Apple's format of looking at things, or it was maybe a news site, and I made my fake press release about we're switching to AMD, and I made it look like it was at like Apple.com, but I used the @ symbol, and it was actually at some website I controlled. The @ symbol used to be used for saying log into this particular website, but so many people have used it for spamming and trying to scam people with phishing attacks that Firefox pops up the warning, and IE just refuses to let you do it anymore. But it used to be a fun attack to pull on people. Oh, well, a lot of web apps just go ahead and respect it and go to it and not just warn you about it. I didn't know that. That's good. That's not, I would like for you to show me that later on. Okay, but there's other ways of pulling off these kind of phishing attacks. There's homographs and homoglyphs. A homograph is essentially a word that looks like another word, but it's not the same word. Homoglyphs are characters that look the same, but are not the same character. To give you an example, Microsoft and Microsoft, this is actually Microsoft. That's an R and an N, but depending on font, actually those people in the back of the rooms, that looks like Microsoft, right? Because you can't hardly make it out. PayPal versus PayPal. This was for one. IronGeek.com versus IronGeek.com. I think somewhere there I have a 0 instead of a, what did I do to screw up that one? Yeah, 0 instead of a O. So there's all sorts of homographs you can do without necessarily resorting to Unicode. But in Unicode, there's all sorts of fun stuff you can use. Letters, digits, hyphens. There's all sorts of stuff. All right, let me see. Here's the problem with doing this for domain names. DNS in and of itself is just straight up ASCII. You're not allowed to use the higher characters. Generally, you can use there's only so many things you can use, and that is letters, digits, and hyphens. So you can't encode some of these higher Unicode characters directly. So but they want countries to be able to, well, let's say you're a Chinese company, and you want your Chinese character, or set of characters to represent your domain name. Well, they have to have a way to allow for that, but DNS doesn't directly allow you to do that. That's where IDNA comes in, and Punycode. Basically, it's a way of taking some character set that's not, plain Latin with those certain restricted DNS characters, and transforming it to something that DNS will allow. For instance, cafe with the little girly E gets transformed to this. And this particular set of Chinese characters gets transformed to this. And those you actually can map in DNS and make them work. Well, the problem with this is, well, first of all, this E looks a lot like a standard E, an E without a diacritic. But if you go into languages like Cyrillic, there's a lot of characters that look exactly the same as the Latin counterparts which we use. For instance, Google. This Google right here is using an E from Cyrillic character set, and it looks like Google, doesn't it? But this is its actual transform to make it into Punycode. Same thing with iucreditunion.org. That's the bank I use, so I was like, now you all know where to hack me at. PayPal, similar thing. Someone did a talk at ShmooCon many years ago on messing around with PayPal using attacks similar to this. And it's using a Cyrillic A for the second A. But this A looks exactly the same as this A. But string-wise, they're not the same, and you can register this. Well, depending on the registrar. We'll get to that in a bit. There's all sorts of sources for homoglyphs. Cyrillic character set, the A, the C, the E, the O, the P, the X, and the Y, all look exactly the same, essentially. There's also full-width Latin and non-full-width Latin. They wanted to be able to take Chinese characters and be able to put another character below them, but have everything still match. And to do that, they need to have that full-width Latin. So you can actually use the entire ASCII set is in there twice. You know, one full width, or the entire Latin character set is in there twice. Once in normal ASCII and once in that full width area. There's even multiple types of slashes which you can use when you're trying to confuse protocol or whether or not something's actually a path or not. So these are all homoglyphs for slashes that you can use. There's also other things that can be used. Like, for instance, I went ahead and set up imgeek.com, and I have set up a DNS entry that this particular slash is not a real slash. It looks like Microsoft.com, and when I mouse over it, it still looks like Microsoft.com, but it actually goes to imgeek.com. And I don't know if that link works at this point. Well, at this point, it warns me about some things. Let me see. Site that looks like the web address may be disguised to look like another website. Remember how I said a lot of this isn't fixed now? So many people are doing this crud that they have implemented fixes to keep people from doing it. And I'm going to say yes to that, and hopefully it's going to pop up. Yeah, and see, it redirected me to imgeek.com. So that's one way of obfuscating. And it all depends on what the browser is and whether or not that's going to function. But if you ever want to mess around with these homograph tags, actually going in and looking up the individual Unicode character is a massive pain in the ass. So I've developed a little tool for you guys to play with. And let me see. My homoglyph attack generator. Check this thing out. All right, let me say I wanted to impersonate irongeek.com. Well, it shows me a bunch of likely homoglyphs. I can choose a different one. Like, for instance, I can choose a different I. I think this one might be one of the Cyrillic ones. And I can now go down here and actually see and copy and paste this new domain name, which has that different I in it. It's not a normal Latin I. And when I mouse over it, notice how the browser shows me down the bottom left-hand corner that it's not actually irongeek.com. I can also generate some punny code for it. Let me get that going again. irongeek.com, different I. I'll just choose any old I. And I can take this down, copy and paste it, and encode or decode it and find its punny code. And now I have its punny code that I can use. Nice and fun stuff. I also have a list of these common ones that you can use down at the bottom. That's a homoglyph attack generator. One of the things I've been messing around with doing with this is also trying to impersonate people's usernames, different places. Like IronGeek may be taken someplace, but IronGeek with a different character may not be. Oh, another cool thing you can do, the reverse character. Actually, I am not. I did try to be that, but I'm not. We'll get into the reverse character here in a bit. This is actually a cool thing. I'm going to show you a little demo of this in case anybody's getting bored. What are these two file types? Let's see if I can. Let me see if I can zoom in on that. Large icons. What type of file is this? It's an email file, right? What kind of file is this? All right. Notice something weird here. If I scroll down, notice I have some other text files in there that don't have, that are using a different icon, because I have something different set up to be my text reader. If I was to actually run this, and by the way, I do have show file extensions turned on. Gotcha. Gotcha. Those are actually EXEs. I'll show you how we did that in a second, but it all involves this reversing character. But that's the attack generator. Now, I was saying before, this has largely been fixed. I mean, there's probably some ways you can still screw with people on this. Firefox now shows punny code unless it's one of these top-level domain names. It also, there's a setting you can set in the advanced config to be able to make it show punny code. And you can also, it also blacklists certain characters that you just can't use in punny code that it thinks might be confusable or weird, and that's this set. And you can find updates here for the blacklist characters, but if this appears, it's automatically going to say, I'm going to show you punny code no matter what. At least that's my understanding of it. Now, IE10, I wasn't able to find a whole lot of information on. I imagine it was the same as old IE7. I couldn't find what they're currently doing. But if there's a mismatch between character sets, it's likely going to show you punny code in the URL. For instance, if my character set is mostly Latin, but then all of a sudden I'm using something that's not matching, like something from Japanese that happens to look like a slash, it's going to say, this isn't quite right, so I'm going to show it to you. It could also likely give you warnings. And if the character is not used in any language, it's probably also going to show you punny code. I mean, generally in IE, it just pretty much always showed me punny code for everything. And you can find some information on IE7 on Microsoft's site. I can't find exactly how 9 and 10 seem to handle it, but it seems to handle it the same as 7 as far as I can tell from hands-on testing. Now, punny code, it shows punny code, sorry, Chrome shows punny code if the language of the browser is set to something different than what that character set inside the punny code is showing. So if I start using this stuff in Cyrillic, but my local character set is just plain old standard US English, well, it's going to say, no, this is probably wrong, I better show punny code. And there's also a whitelist of what can be allowed. And it keeps a whitelist of things that, well, a blacklist of like incompatible character types that shouldn't be mixed together in a domain name likely. And we'll go ahead and show you punny code. There's also characters in a blacklist. There's also defenses that are done by the registrar themselves, and they won't let you register a domain with certain names, or certain characters in the name. For instance, I got this from one of my registrars when I tried to use a Cyrillic I, and it would tell me that it would not let me do that because it was an invalid international character. So there's certain protections that registrars have been doing. However, when I tried at that point, it did let me get through with this character from, I think, Japanese, this little slash. And so you're always around it. Also, if you own the domain yourself, you can generally just, once you have the DNS set up, you can just set up things for yourself and try to confuse them by using the slash. So I want to go through and test them. So I basically came up with my own set of punny code URLs to test with. And I wanted to look at them on different browsers and see what appears in the URL bar. I also wanted to test them and see what it comes through on email, and also how social networks render the URL. And I did this test with IE, well, here's the particular versions. I did these tests about, I don't know, 2 months ago, so I'm assuming they haven't changed much since then. And what I got when I tried to generate all these is Chrome and IE9 pretty much always showed the punny code. It's actually easier to spoof in Firefox. And I don't think that was Firefox 11. I just don't think I updated the slide. I was using Firefox 23 something when I did the test. So I tried to use omega.com. Well, in one way, Firefox showed it as omega.com, just a lowercase omega. It used to be it showed me the punny code. IE9 and Chrome both showed me the punny code. I tried it again, omega.org. And here's another thing. In Firefox, a .org, remember that blacklist I showed you of we only allow international domain names with certain top-level domains? Well, .org is one of the easier ones to spoof because a .org could be in China, it could be in some place in Lithuania, it could be any of these places. So those are generally easier to spoof, which is why when I was picking on a bank, I picked on IU Credit Union because, well, they end with a .org. Other banks end with a .com. They're a little bit harder. The Chinese characters, I think this was some university perhaps, it came out as Unicode in both Chrome and IE, but in Firefox, it came out as the Chinese character set. When I tried Google.com, everybody did that as the punny code. IUCreditUnion.org, though, I was able to get Firefox to make it look like IUCreditUnion.org, and it's not the real normal U, it's a Cyrillic U. But Chrome and IE, they show it as punny code, so you can't really spoof that. Oh, remember I was talking about ASCII being encoded more than once? There's a fun thing called normalization. I try to use the wide Latin Google to see if I can make a different Google. That doesn't work. I use these code points. When you do that, your browser automatically normalizes it to normal Latin. And we'll talk about some exploitation using normalization here in a bit. Let's see. Oh, and also, when I tried this particular trick using a slash, everybody also showed punny code. So you can see, other than some issues in Firefox, punny code is no longer a real easy way to spoof domain names. Though it could be argued that while Firefox is easier to do these kind of phishing attacks and spoofs on, it's really because it supports punny code better, because IE9 and Chrome largely, go to screw it. We're not really supporting it. We're showing you everything in punny code. It'll interpret when you type it in, but it shows you the actual thing. So it's kind of missing the point. So Firefox is better supportive of Unicode in some ways. It's actually a detriment depending on what your goals are. I also tried some other oddball encodings and seeing what I could and couldn't register. I was able to register these, or I would be capable of registering these particular sites with slightly different eyes. Like this one here, the ogonek, this particular eye. You notice how the underline kind of obfuscates the fact that it's not a normal eye. So all these pass the registrar's tests. And the little slash here, that seemed to work fine in Firefox, but not in Chrome and IE. All right, I also want to test to see how these displayed, not just in the browser bar, but when someone looked at them in a web app. And so I used a bunch of test strings and put them in the various web apps and also emailed them out to places. Now, Outlook 2010, when I sent a mail there, because I was using all these mixed character sets, it warns me that it's potentially unsafe. Though apparently this is a setting you can make either in a GPO or on the Exchange server, because I've seen another Outlook 2010 install where it didn't give this warning. And also, it sometimes mangled things. Like when I used that special Unicode slash, it put it into 2 different URLs instead of 1 URL. And also, this little I in iucreditunion.org, it didn't think that I was part of the rest of the URL. So it mangled it pretty bad. So that wouldn't be very good for phishing. I sent one from Outlook to my Gmail, and it had similar results, but it didn't get the I, and it separated out the URLs. And let's see. Facebook seemed to render them all pretty much the way I'd want, except for the 4th link, which it just didn't link at all. And the slash didn't seem to bother it at all as far as making anything 1 URL when it automatically tried to assign things. So Facebook, well, that was the result I got from that. Twitter messes things all up, because when you start doing that CRUD, it's automatically, well, split these 2 into 2 different domains, so I couldn't do my spoof of my own DNS for irongeek.com, making it look like Microsoft with that slash. And it had the same thing of not seeing this I as part of the URL. And for other things, it just decided to show the punny code so I wouldn't be able to confuse people. And that's the way those showed up in Twitter. Also, something to keep in mind with these homoglyph attacks, font matters a whole lot. And if you want to get away with something, and this, by the way, I did this slide way before someone decided to take Dave Relick's name. I wanted to do that, and I was trying to do that, but I didn't exactly succeed. There were 2 different Dave Relicks here, and these 2 look the same in Calibre, but in Courier New, not necessarily, because this L and this I look the same in Calibre, but it's an L and an I here. And so it all depends on what font is being used or whether you pull it off. And this one, I'm not even using the higher Unicode stuff to be able to pull it off. I'm just using straight up ASCII. Because one thing I've noticed, if you go into Twitter and Google, they will not let you register a domain, register a name with these higher Unicode characters. It has to be basic ASCII, which is sad because it would allow me to do all sorts of fun things. Like I wanted to impersonate Kevin Mitnick at one point. Okay, that's the basics of homoglyphs. But what else can you do? Oh, I should note, I did do some messing around with, I think I have it in a second. I think I have it in a later slide. There's some other things you can do with homoglyphs to a degree. Steganography, basically hiding stuff inside of stuff. Who's ever messed around with steganography? The classic example is take an image, take the last little bit of the character, or the last bit of a byte encoding a particular bit, and go a pixel and say, okay, it's red. I'm going to change the last couple bits of the byte set that's representing that pixel and change it up or down a little bit to encode extra data. And by doing that, you're only changing the value of that red only slightly. It's unnoticeable to the human eye, but another reader can read on the other end and extract the data out of that image. What about doing this in text, though? People do this in images and videos and crud like that. Is there a way you can embed it inside? Well, I decided to use homoglyphs and other features inside of Unicode to try to make my own steganography. And it's a mixed results. I mean, a lot of times it looks good to the human eye. A software package could easily scan for it and find it if it knows to look for it. But I want to show you a demo of doing that. Let me see. Get my web browser back up. Here I have my Unicode text steganography encoders and decoders. So let's say I wanted to encode something and say, "Hi, Brian. This is my cover text." All right, that gives me some ability to encode. And now let's say I want to encode something using Unicode tags. I can type in, "This is hidden." Encode that, and there we go. I can now copy and paste this out to Twitter, and if someone wanted to decode it, they could. How about we do this instead? All right, Unicode Stego at HackerCon. Yippee. And now let me go ahead and encode this. Copy and paste this encoded text. And I'm actually going to send this out to Twitter. Maybe. If that actually comes up. Well, while that's coming up, let me go ahead and bring up some of the other ones. That one right there is using Unicode tag Stego, and I'll talk about what that is in a bit. There's other ones I have, like this is a more advanced one that uses the homoglyphs to be able to encode things. I can only encode 28 bits. I have 90 to do. All right, let me shorten that down, because you already encode so many. I can encode 28, and I need 28, so now I have a different one. This one is using the more advanced Stego, and if you actually looked at this, you would notice that these E's and sometimes are replaced with the Cyrillic E's, similar things for other characters in there that have very close homoglyphs. And Twitter is just not being a happy camper whatsoever, so we won't actually paste that up. But sometime or another, go out there and generate them. I'll show you what the results end up looking like, though. Oh, by the way, you can also use this for botnets. I did some work on a botnet in Twitter that used Unicode characters to be able to transfer stuff back and forth but make it look like a conversation, which had mixed results. So when I did this, I had different ways of doing Stego. One way was to do full width Latin and normal width Latin, but that looks kind of ugly. Here it looks okay, but what I did was I took, if I wanted to represent a 0, I did the lower ASCII version of that Latin character. If I wanted to represent a 1, I would use the upper one, and that was as easy as just adding hexadecimal, well, actually adding decimal 65,248 to it. And I represented the space with something different. So that worked pretty well on some browsers, but other places it would have this weird effect I'll show you in a bit. It looks like a Ransom letter where they cut and paste stuff out of a newspaper. Now the more advanced Stego one I did, it's kind of cool because I decided to only use homoglyphs that were very, very close. So it looked almost exact. Because some O's are slightly off and you can tell, especially if it's next to another O. So I used these particular characters and tried to use them to encode 0s and 1s. And some things, like I was actually able to use like spaces. There was enough types of spaces that were different. I could encode 3 bits in each character, which was kind of cool. And those came out looking pretty good most of the time. Another thing I could do, those non-printable tags that were kind of meant for like marking up text. And the entire ASCII set is inside those tags. So you can go in there and use them, and they don't actually show. The one I was trying to tweet out earlier, it actually, if I was to ever able to actually get to Twitter, let me go up here. If I was to copy and paste this, anybody wants to try this? This actually uses those tags I mentioned, and it's invisible characters. I'm going to send that. I hope I was going to send that. Egads, what is your problem, Twitter? Maybe I'll send it later. I'll show you what it ended up looking like, though. But it's also easy to encode because you just have to add a number to each character you wanted to put in there. So all those are examples of hiding text inside of other text. Now here's how it ended up working. On IE, it all worked well most of the time. The Unicode tags came out perfectly. I can copy paste that back in, and in the spaces here are all those tags that actually represent my hidden text. Also, the advanced one worked well. However, but ugly wide Latin one, you notice how everything is a little bit weirded out. It's like the characters don't quite match up as far as size. That's a side effect. It actually is even worse in Firefox for that one, but the other two encoding types work just fine. But yeah, but ugly wide Latin, it becomes real obvious someone's up to something. And Chrome, you had similar effects. Now Chrome had one other side effect. Remember I was mentioning that I have text encoded inside here? The phrase I actually have encoded inside that in Stego is, it worked. And well, here you see where I encoded it, it puts a non-printable character symbol in Chrome. So I can't get away with this on Chrome. And other things had different results. I tested the same thing, but sending a message in Outlook from Gmail, and you see that it automatically put those replacement characters there. Advanced Latin worked okay, but I think some spaces got stripped, and the wide Latin looks hideous. Another thing you can do with all this is, actually, so people can actually test it, I'm going to see if Chrome ever actually come up. Sorry, did Twitter ever actually come up? No, it did not. Lovely. Well, that's the kind of thing I can't do anything but a live demo on. I don't want to see you right now. Go away. All right, name spoofing. I was talking about doing things with Dave Rillick before. I can't, unfortunately, register Unicode characters in my name in like Google or Twitter. And I don't think Facebook was letting me do it either. But there are other systems that will let you do that. For instance, I tried to impersonate Darren Kitchen on the Hack5 forums, and I could use the Greek capital letter kappa to be able to change, I believe that was the K here, and impersonate Darren Kitchen. Now, it didn't exactly totally work because if you looked at the follow account, it became obviously I was not him, or sorry, the number of messages sent, it became obviously I wasn't him. But you can sometimes impersonate names. And I want to look around for more systems that this might be a particular flaw in. I know it's a flaw in certain forum systems, but it's kind of compensated by the fact that if I try to impersonate someone important on it, it still doesn't let, people will know because they, hopefully, if they pay attention, because the post count would be different. Twitter, like I said, it gives you an error message if you try to do something similar when registering a name. Same thing with Gmail. But I want to see more research on this. If anybody knows some applications that think might be vulnerable to this kind of attack, let me know because I'd like to try it out, impersonate some people. All right. There's also that right to left trick I've shown you before. Remember those EXEs that weren't EXEs? Here's the way that worked. You can use a right to left character, and well, certain characters sets, let's say like Arabic and Hebrew, where everything's supposed to be written or read right to left. So you can use an override and flip characters. And what I basically did was, take, for instance, this one's irongeek.com. I can use the right to left character set and make something look like the right to left override and make something that looks like it's at Microsoft.com actually be at irongeek.com. Because if I reverse this, it looks like Microsoft.com/com. Or you get the picture, hopefully. There's some details out there for doing this. And that's where I made those file names. I basically got to a certain point. Once I got to an lme.exe in the name, well, right before the L, I put that right to left character switch, and it allowed me to make an email that looked like, make an exe that looked like an email file. I just replaced the icon in it using an editor or compile it with that particular icon, which I extracted from the tool that was supposed to be opened in. One thing, though, about those EXEs, if you went out to a command prompt and did a directory listing, it'd become obvious that they aren't text files or email files, because that right to left character marker is going to be replaced with a question mark. There's also non-visual attacks that someone might be able to pull off, like those UTF-8 exploits. We'll talk about text comparison, buffer overflows, property and character stability, deletion of code points, secure encoding conversion, and enabling lossless conversion. This is all stuff that they talk about in a Unicode report on security, which is good to check out. By the way, these slides, well, a version of these slides is already up on my webpage if anybody wants them. I was wanting to look into canonicalization errors. Canonicalization errors is basically we have something in a character set that gets replaced by something else to make things standard. Let's say you have a database, and if you think, you know, all quotation marks are the same, well, you'd want to canonicalize the real curly question mark, all quotation marks are the same. You want to canonicalize all those, that's a hard word for me to say, those quotation marks to be one type of quotation mark. Otherwise, it'd be really hard to search through text. Well, let's say you have something like a greater than or less than symbol. What if that is canonicalized if you use a different one? Like here's greater than and less than symbols in several spots in the Unicode set. What if one of these higher ones, let's say when someone's filtering for XSS and they look for the normal ASCII ones, but you're actually using one of the higher level ones, they filter first and then they canonicalize afterwards? Well, if they canonicalize afterwards, this gets past the filter, because at the point in which it was being looked at, it wasn't this particular lower ASCII greater than and less than symbol. There's all sorts of other transforms that can get people also. Let's say this particular character that looks like a B, apparently in uppercase it becomes an SS. This I, it becomes a script, it becomes a lowercase I. You could use this possibly if something's going through a case conversion to get the word script for a cross-site scripting attack through a filter. And there's several others that have weird transforms depending on what the language is set up on the computer and whether or not the software actually bothers to do it. And look up case folding for that. Also, there's weird UTF-8 exploits, like overly long UTF-8 exploits. You remember this is many years ago. This is about 14 years ago. There was a vulnerability back in 2000 where you had a dot slash and you can do a path transfer. So what Microsoft did was they looked for a normal UTF-8 dot slash, and that was represented normally as I don't know if I have what it's normally represented as here. It's normally represented as a smaller set of characters. However, you can do an overly long Unicode 8 version of it, and that would allow you to get past the filter. Because it would look at it and it would go, all right, this is not normally encoded in more than 3 bytes, but you encode it in more than 3 bytes using the continuation bits from UTF-8, and when it gets past the filter, just fine, because it's not the same type of bytes, but then it gets canonicalized to the dot slash, and it allows you to do the path transversal. But that was something you used to be able to do in an old version of IIS. And to give you another example of that, I have some corrupt HTML. I'm going to show you this, not HTML, the corrupt text. Let me see. Yeah. See this corrupt text? Let me take it out, hex view. I've gone in and mangled it and made some invalid characters. For instance, right here, here's some overly long UTF-8. Now, those bytes are not representing the normal less than, greater than symbols. However, this particular application canonicalizes them down to the short form. So if I copy and paste that, or if someone tried to correct the bugs, it would replace it with the characters I actually want. And you have a similar effect with that MS0057. And you can do other types of corruption to be able to hopefully bypass filters as well. All fun stuff to play around with. I'm getting close to the end here. All right. There's also problems with text comparison. When I was mentioning things get canonicalized, you can have different ways of, well, let's say you wanted to filter for some reason A with this diacritic mark. There's multiple ways you can do that. You can have it as its own single character, or you can have it, which is this, or you can have it with a diacritic character right next to it, and hopefully the renderer will automatically know to put the diacritic above it. You get mixed results in this. There's also other normalization forms, like this delete gets turned into this delete if it goes through, I believe it was NFKC, normalization form compatible composition. And the reason you want to do these canonicalization, again, is like you're doing text searches inside of a database. If you represented delete as this one time and delete this as a different time, that would screw you up. Or if you had this character in a database, and sometimes it was represented with a 41 and a 300 hex, but sometimes it was represented as a 00C0, that would be a pain for searches. So you want to canonicalize for that very reason. How are we doing? Stopped? Oh. Some real-life examples of this actually biting someone in the ass. Canonicalization of usernames. They had something on Spotify where there was a problem where something was not called, a function was not what's called idempotent. I don't know if I'm pronouncing it right. It sounds embarrassing, doesn't it? What that means is running the function, if a function is that, running the same function on something multiple times won't change the outcome if you do it multiple times. For instance, two lowercase. If you take a string and run two lowercase on it twice, it's no different. It's still lowercase. So that's fine. Well, this particular function they were using for canonicalizing it, the first time it was ran, it would have one output, but depending on what the input was, it would have a different output the second time it was ran. So someone decided that they could go in and make their own username, like Iron Geek. Instead of writing it with the normal ASCII characters, they wrote it with this set of Unicode code points. The first time that got canonicalized, it got canonicalized to this, uppercase Iron Geek. But when a password reset was done, someone could put in this, and again, it didn't get canonicalized to the same thing. It got canonicalized to, well, sorry, I'm going to probably put this. Someone registered, let me read through this exactly as it says it, because that might help me out. A user signs up with Iron Geek, and it normalizes the Iron Geek lowercase. Another user signs up with this particular phonic extension block, and when it gets normalized to uppercase Iron Geek the first time, but lowercase Iron Geek the next time. These aren't the same, so it was allowed them to register. When the person tried to do a password reset, it canonicalized it again. This time, though, it became the normal Iron Geek's account, this one, and they were able to get the person's password, or be able to reset the person's password because of this canonicalization error. You get my drift. There's a whole write-up on there that probably explains it better than I just did. All right. Also, people can use it to thwart obscenity filters and searches. For instance, I started looking around for different types of porn on the internet, purely for research purposes. And I used different O's for porn, and I came up with totally different results for this. Some people used to use like prawn for the similar results. But yeah, try looking at different O's. I also tried looking for crystal method. Not crystal, sorry. The band was there and it messed with my brain. Crystal meth. And depending on what E I used, I got different sites. So some people seem to have tried to use this to get around search filters, but also you can use it to get around spam filters in some cases. However, people have caught on to that, and a lot of times just using these characters will automatically cause you to get thrown in a spam folder. Now, I was also messing around with Unicode some a while back for messing around with diacritics. Diacritics are those little extra bits of accents they put on top of another character. Well, there's different ones out there, and this one, I actually tried to write red rum, red rum, red rum, red rum over top of everybody else's tweets. And because it's a diacritic and it was stacking, I was able to get that to go up over other people's tweets and just really confuse people on Twitter, which is fun. That was mostly just fun in games, though. And also, depending on what was reading it, you may not get a result at all. This is similar to what you might see on 4chan, the whole Zalgo text, where someone has this like demonic-looking text and has characters all over the place. It's because they're using different diacritics to make that effect. Another thing that's possible, but I haven't seen implemented yet, is a buffer overflow using this normalization, because there's sort of standard ways of normalizing something. And let's say you have this particular character. Well, some of these get canonicalized to something larger than they originally were. So let's say you judge the size of a buffer to start with, this being this many bytes. It's like, okay, so this will fit. I can pass it on. But the next step is to canonicalize it and set it in the same buffer. Well, this thing gets expanded, this particular character gets expanded 18 times when you normalize it with this particular normalization. And that could have some side effects. So I think that one is like something in Arabic for like, God is great, or I don't recall at this point. Also, one thing to keep in mind, Unicode implementations can also cause problems with buffer overflows. Have you heard of Venetian shellcode? If something gets written in, well, let's say I was going to take a bunch of A's. Well, depending on the operating system, that might get put into UTF-16, and that would be represented as 0041, 0041, and so on. Well, what's a 00 in a string in standard C? Null terminator. So that would kind of screw up people doing shellcode. So someone came up with a way of doing Venetian shellcode to get around this problem, and there's a couple of good presentations out there that you can go check out. I think I first learned about him from Carl Encoder, but FX has a presentation on it, and a lot of the work was done by Chris Ainley. Another thing to be trying is fuzzing. I'm really curious what will happen when people throw various characters into different software and see what happens, how things are implemented. Like diacritics especially. Like I saw all sorts of different results depending on what browser I threw those diacritics in. And when I was looking at my tweets that I was using them in on a phone, totally different results. But try to combine different diacritics, use those invisible characters, do that malformed UTF-8, bad surrogate pairs in UTF-16, see what you can actually pull off, or multiple levels of right to left reversing. And this has actually come out where people have had problems with this before. I think Chris Webber has a blog entry on some of these kind of things. But remember, like, I think it was like 2 months ago, Apple had that bug where everybody's Twitter client kept crashing because someone would post this string. Well, that particular string was crashing that version of iOS because they had a bug in the Unicode implementation. And there were similar things on Microsoft's side as well within the last few months. Oh, Dale Hyland, by the way, he was messing around with and made a shorter version of the above string if you need to fit it in something smaller. He's actually been messing around with exploiting people's wireless using corrupted SIDs that have bad things in them, like cross-site attacks and similar. Well, apparently you can put this and I think screw up some Apple software if you set his little string as your SID in your wireless network. So fun stuff to be playing around with. Oh, I'm about done, and I want to say big thanks to a few people. The person who first got me interested in Unicode was Jay Ablams. I saw a talk on his on Punycode a few years back. Back then it was probably still more of a problem, and it seems like a lot of people have fixed it since. Chris Webber's probably done more research on security in Unicode than anybody else, so definitely check out some of his old presentations. Michael Zawinski, he wrote a book called Tangled Web, which also got me interested in some of these Unicode bugs. And William Coppola sent me a string that he was using to crash clients a while back. So he was helping me out as far as, inspiring me to look more into, well, fuzzing applications with this. So that hopefully will lead to future work. There's a ton of useful sites, which I've already covered, and you can go look in the look later on my website for these. And also just some general fun things, like if you want to do all sorts of weird text inside of Twitter, check out Unicode fonts where different characters are encoded different times. Also, there's this one for compressing your tweets, which is a fun thing to play with. Art from this guy, references you can check out on the slides later on. Come to DerbyCon next year, I needed to update them. I updated the dates, I didn't update the year. And finally, are there any questions? But I think most people want to eat, so thank you very much. Actually, are there any questions? All right, thank you very much for your time.